Scientists have been experimenting with a wild idea, looking to nature for inspiration in the design of new machines and robots. The goal? To improve devices and innovations to transform medicine and much more. Miles O'Brien reports for our Breakthrough series on the leading edge of science and technology.
In the never-ending hunt for new designs that jump, pump, or run faster and better, scientists are finding inspiration when they look out the windows of their labs or in the mirror.
Almost everything that we are trying to do in engineering is actually really in some ways trying to replicate the beauty and the intricacy and the complexity of what we find in nature.
Bioengineer Rashid Bashir and his team at the University of Illinois are developing so-called biobots that move using real muscles activated by flashes of light. Bashir sees lots of potential applications, like toxic cleanup or tiny clot-busting bots to treat people with heart disease.
What we're doing is trying to recapitulate what exists in nature. So now the idea is that, well, can we start to learn some of those design rules? How can we build non-natural systems with these living cells?
Bashir's work is part of an accelerating trend. Welcome to the odd and yet familiar world of bio-inspired design, or biomimicry.
Biomimicry is innovation inspired by nature.
Janine Benyus is a biologist and writer who popularized the term, writing a book on the subject in 1997.
Take methane and turn it into plastics.
She remains in the vanguard of the field.
You have novelty and sustainability. That's why a lot of inventors are now turning towards biomimicry.
Physicist Seth Fraden is among them. He directs the Bio-Inspired Soft Materials Center at Brandeis University. Here they want to understand the fundamentals of how living things move.
We're talking about blurring the boundaries between the animate and the inanimate.
He and his collaborator Zvonimir Dojic are working on artificial cilia, tiny hair-like projections on the surface of cells. They work together in sync to move fluids. While these cilia are microscopic, they could lead to the development of more sophisticated materials to carry out more complicated tasks, like pipes that need no pumps.
Your heart will pump fluids, your intestine will pump fluids. Now, if we want to pump oil through a pipe, we have to have a pump at one end and create pressure to drive it. Why can't we have tubing that consumes energy from the fluid that flows through it, much as our heart consumes the energy from the blood that flows through it and then contract?
Is it alive?
No, it's not alive. It's just a simple machine, but instead of having an external pump that's composed of many dead components, a fluid is composed of millions and millions of individual components, and under certain conditions, all of these machines go in a certain direction and push fluid with it.
Kostya Kornev and his team at Clemson University are also looking at nature's means of moving fluids. They are focused on the mouth, or proboscis, of butterflies to inspire a breakthrough in materials science. Kornev and his team want to make synthetic fibers with similar properties. Eventually, they want to build a micro-siphon that would suck up or dispense tiny drops of fluid. Such a device would have wide-ranging applications, like new medical tools.
So you can think about poking the single cell, taking a little droplet from particular, say, the nucleus or somewhere in the spot of the single cell, or if you can go to the brain and do the surgery on the brain.
Roboticist Sarah Bergbreiter is thinking along the same lines. She and her team build tiny robots inspired by insects, which can be impressive jumpers. Fleas can leap 200 times their body length.
What we can do is compress this and store energy in those rubber bands and release those for a jump.
Bergbreiter sees a day when microbots could carry cameras and sensors into small places for surveillance, perform microsurgery, crawl into cracks to monitor the structural safety of buildings and bridges, even deploy on search and rescue missions.
My picture is always you have a bucket full of these small robots, you dump them into rubble after disaster, and they have just enough energy to find somebody and say, hey, dig over here.
She builds her robots using 3D printers. This burgeoning manufacturing technique enables engineers and inventors to think out of the design box that has existed since the advent of the Industrial Revolution. Near Boston, at 3D printing startup Desktop Metal, they're using artificial intelligence to do the designing. Engineer Andy Roberts tells the machine what stresses a part will encounter, and the software does the rest.
This is a nature-inspired tool that is intended to make it easy to create these crazy-shaped parts here. In this one, we're growing 3 different stems towards a common target. And while they look like 3 organisms right now, they will join together and fuse into a single one. This ability to simulate these random and cumulative forces that you see in nature all the time tends to give these parts a more resilient overall behavior.
Check out this AI-designed skateboard.
I've triggered the growth of this design from a single seed cell on the base plate down here.
So when the machine is told to design a machine, it makes something that looks like it belongs in nature. Oh, the irony.
Ultimately, the truly biomimetic idea is that you're functionally indistinguishable from the wild land next door.
But it does stand to reason. After all, nature has been perfecting designs for 3.8 billion years. For the PBS NewsHour, I'm Miles O'Brien in Boston.